Okay, so we are doing sort of a companion piece for the Kaplan 2021 GED Prep Plus book, which is a great book. If you're using it, this is a companion, not to replace it. It is the best book out there and all that. So what the general thing of what these videos are is going through one of the practice tests and going, this is the, we can glance at it real quick. These are the subject areas of that test, of the practice test. It's not about getting that practice test right. It's just here's sort of the samples. We're not learning things in order, really. We're just, because that's not how the questions come. It could be a geometry question. It could be next to an algebra question. It's just sort of, getting used to the width and breadth of everything that gets covered. This one is a little bit different. This video is a little bit different because we're going to be doing something that's in between. We got to fill in a gap real quick. Order of operations is what we just worked on, and the please excuse my dear Aunt Sally. So please excuse my dear Aunt Sally. We just did a question on that. It's not really an exception to the rule, but when it comes to parentheses, there's one property we really have to know, and that's called the distributive property. So please excuse my dear Aunt Sally. Dear Aunt Sally says, do everything in any parentheses first. If there's an operation there, you got to do that work first. So it would be, 8 plus 3. Whatever's going on outside here, we got to turn that into 11 to get rid of the parentheses. There's this thing called the distributive property, and there may be a few different ways that they ask about the distributive property on the GED test. In fact, one of the ways that almost for sure is going to be there isn't on the Kaplan test or in the Kaplan book. But anyway, this is the basics of it. So I'm going to draw up 3 plus 2 in here, and I'm going to put a 7. There's nothing in between here and here. There's nothing. And when two things are touching, letters and numbers, that means multiply. There's no sign in there. When things are touching parentheses and there's no sign to say what to do, it means multiply. So this means 7 times 3 plus 2. Now, dear Aunt Sally says, add these two together. And now 7's still hanging out there. We got to remember to write a little times dot. And then we'll do it. We'll get our answer, which is 35, which is right. That's the strict, please excuse my dear Aunt Sally, way to do it. There is something else that will be tested on. It's not just useful. This is something we got to know going into the test. Instead of adding these two first and then multiplying, so adding the parts and then multiplying, you can multiply the parts and then add them. It's a small exception. And we're going to have to know how to use this. This is a have to. So instead of 3 plus 2 becoming 5 and 7 plus 5 is 7 times 5 is 35. We can jump the fence and do 7 times 3, which is 21. And then 7 times positive 2. If this was minus 2, it'd be negative 2. And that would be positive 14. Add the parts together and still get 35. So both ways are the same thing. So I'm going to draw something down here and explain it, because this is the thing that's not on the Kaplan test that I've seen on the GED site a lot. This is the math of the distributive property right here. So if they said, what is, which of these equations draws out the distributive property, this one does it, because it's the jump the fence. Here's the original problem. This is the same as that. Oops. This is the same as that. And then this bit of math right here are these lines drawn out. So that'll make sense here in a second. So again, you could add these two together, get 5. 7 times 5 would be 35. But if you multiply, if you distribute, I don't know why that's the word, but you're distributing the 7, whatever. The 7 times 3, that's that part, is that line right there. And then 7 times positive 2 is plus 7 times 2. So that's called the distributive property. Distributive property. So that's that. Now here comes the tough part. Made your eyes roll. Why we need to know this is because there's some times where we cannot add or subtract what's going on inside the parentheses. Dear Aunt Sally says strictly do what's in the parentheses. 2x plus 3 means 2 times x, a number we don't know, plus 3. We can't add those two together. They're from different families. This number is from the x family, and this number is from the just a number family. Can't add and subtract them. We can multiply them, but we can't add and subtract them. So this is where we're going to distribute. We have to. Dear Aunt Sally's doing this. We're like, Aunt Sally can't do it. She's like, figure out a way. And that's distributing. We're going to jump the fence and multiply that. 4 times 2x is 4 times 2 times x. Well, what am I supposed to do? Do what you can. Can you multiply 4 times 2? Yeah, you can get 8. And there's nothing here to multiply with x, so it just comes down here like baggage. So if you look at it, that's not so bad. 4 times 2 makes the 8, and the x just comes along down. Then we jump this fence over here. 4 times positive 3 is positive 12. So this, let's see if I can erase this carefully. These two things are the same. What's the tough part is asking, how do I know I'm done? Because this doesn't look finished. There's nothing about this that looks finished. Well, that is a tough thing when it comes to expressions. Expressions are, could be multi-parts, but how exactly do we know when we're done? The way we know we're done is the families. That's everything in the X family is together. Everything in the just a number family is together. That means we're done. Think of the silverware tray, forks, knives, spoons. If all the forks are with the forks, the knives are knives, and the spoons are the spoons, you're good. Another way to think about it when it gets overly complex, like seating people at a wedding according to families. You want all of the X family together, all the Y family together, all the Z family together. That's when you know what you're done. The term for these is polynomials, nomials, or binomials. Nomials. Nome just means name, literally. Like en español, ¿qué es tu nombre? It means name. So nome just means name. Poly means a lot. Bi means 2. So this would end up being a binomial because there's 2 last names. Do we have to know that term? No. But I just wanted to show you that a complex, big old math word like that just means lots of last names. Binomial just means 2 different last names like that. X family, just the number family, and just like the family feud. So that is one extra way that we're going to handle the please excuse my dear Aunt Sally rule, is distribute. When you see stuff that we cannot quite deal with by following the rules normally, by doing 3x minus 3, you can't do anything with it. But this 7's out here. We jump the fence, and this 21x. That's all it is. Do what you can. And this would be 7 times negative 3. The sign travels. 7 times -3 is -21. This is done. Forks, knives, spoons. Families are seated together at the wedding reception. We're ready to move on. So that is the distributive Florida. The distributive Florida formula. I'm losing my mind.